Hello, I'm Bill Rader, co-founder and chief executive officer at Efferent Labs. We've talked a little bit today about cancer and the effects of cancer on people. In this presentation, during this time, there will be about 30 people diagnosed with cancer in the United States, and about 7 of them will start chemotherapy at some point in the future. Cancer itself is a cellular disease. Each case is individual and unique in itself. Chemotherapy application currently is done in a way that hasn't changed much since the beginning of the last century. The drugs have changed and improved, but the application of chemotherapy is very similar. The patients are analyzed by weight, height, body surface area, and the doctors take a shot at giving the patient the right amount of chemo. Oftentimes that is too much. In the case of my mother, the side effects from the chemo ended up killing her later in her second round of cancer. If you give too little of this chemo, it's just not effective. The doctors need to target a very specific dose to the patient to really make the difference without over-treating the patient. The reason this is the case is data. The physicians just don't have all the information they need to really give the patient the exact dose of chemo that they require. We have a solution for this, and our solution uses the patient's own cells as a sensor. We've analyzed those cells using photoelectronics or photonics, and we provide a feedback of rich, exacting data to the physician that they can look at in real time and make decisions based on what they see. Now, my partner in this and the inventor of the technology, Dr. Spencer Rossaro, he came up with this idea because he had patients coming to him and talking to him about things. Cheers. I knew it was going to come up in mine. Talking about how they felt and what was happening to them. And he'd do all these tests, and he just didn't get anything. And he's an electrocardiologist, and these patients would come back 2 days later. He'd find them in the emergency room. Their bodies were telling them that something was wrong. And he looked and he said, there's got to be a way we can look at these patients and make a determination as to what's happening with them, because their body's telling them they don't feel good, but we can't see it. And we determine it is their own cells. Now, the way this works is we take our device, which is very small. It's not this size yet, but we're working here. But we subcutaneously implant this in the patient. The device itself has the patient cells in it, and they interact with the surrounding body in the interstitial area. The cells then react, and we examine them photonically to determine what's actually happening. Okay? This data is transmitted out into the cloud, where analytics are performed, and then information is given back to the physician himself on a computer, laptop, or on their cell phone. So it gives them immediate access to look at what's actually happening in that patient and make a determination. Now, current standards, the gold standards here are basically blood tests, and that's for chemotherapy. It's not implantable, it doesn't continuously feed back information, and it's a reactive response to the treatment, where we provide a proactive response to allow the physician a better chance at giving you the best care. This allows the physician to target the dosing directly. Continuous data gives you optimal dosing, and you're going to end up with improved patient outcomes. Now, right now, we've been able to, in the last 2 years since we won 43 North, we've taken a device that was about the size of half a shoebox. Even an elephant wouldn't want that implanted in them. And we've been able to reduce this down to a very small device that is upstairs in my office. Right now, it's the size of about a quarter. And we're implanting this in rats right now, and we're getting feedback from the rats. We've actually got the design already reduced to dime size, but we're focusing on the quarter size to get good streaming data out. We've been able to get great response and have great success in this device last year in our testing, and we are moving into the preclinical market next year, or excuse me, this year, the end of this year. The preclinical market is our first market before we get to the human market. It's a stepped process. We go from animals, where there's an actual return on investment. We go into the clinical market, which is R&D phase testing, and then we go from there, taking all this data into our first human applications. We just announced that we just pinned a agreement with the second largest CRO in Europe. They have about 1,000 employees. And we're going to be starting in March, we're going to be starting 2 simultaneous labs running in parallel in Toulouse, France, doing more data and more work on our product to help us get to the 2017 commercialization of our device in the preclinical market. So I was briefly talked a little bit about the commercialization here earlier. The preclinical market, we're going there first because it's revenue generating, because it provides us revenues to be able to move into the clinical and the human market, and because there's very low FDA barriers in that market. It provides us with good partners and allows us to get to a point to either license or sell this into that market. To date, we've had 4 issued patents, and we have another patent that is pending that we just applied for last year. These allow us to operate freely in our space without the risk of having a competitor come in and steal our ideas. Now, we have a great team you see up here, but most of these people are contractors or people that we use to build this product and move it along, because we haven't got yet to the commercialization of this product. Myself and Dr. Rosario up there on the upper left-hand side have been working on this for several years. We have other people from the science area, from the engineering, and from the IT area that have built some of our software. And we have a very strong board of directors that have helped us get in front of a lot of major people. Now, our milestones are straightforward. On this timeline, we have just entered the partnership with Evotec in the Q1. We've signed that deal, and we'll be moving forward with our device between Q1 and Q2 into the wireless version of this device. We expect commercial sales at the end of this year. So, in summary, we have a biotech product. We use living cells. We analyze this photonically, and we integrate this with software to provide rich data to the physician. We have multiple markets. We have numerous areas to get into market, and then after we're in market, in humans at least, we have multiple other targeted areas outside of chemotherapy that can be of great use. We have a strong IP position where we're submitting patents. Even this year, we'll be submitting some more. And to date, we've been very effective in our use of funds. We've raised a little over $2 million with about half of the money coming from myself and Dr. Rosario up front. We did a 43 North win, and we've also picked up some angel money along the way. We have a really good team, and we believe we're going to be able to take this across the goal line by the end of this year. So thank you very much for your time, and if anybody has any questions, feel free to reach out, and I'd love to talk to you about what we're doing. Thank you.